Hey, Transmath 2 class, we're going to continue on with some multiplying fractions, and in this section we are going to concentrate on the traditional way of doing it, which I have introduced already. We'll also refer to the area models like we saw in the last section a little bit as well. Okay, so starting off, we're just going to review some multiplication facts. So if you want to, you could pause the video or just stop it and fill these out quick. I'll just go through them here. 3 times 8 is 24. 4 times 5 is 20, 9 times 7 is 63, 8 times 7 is 56, 9 times 6 or 6 times 9 is 54, 4 times 4 is 16, 10 times 8 is 80, 3 times 9 is 27, and 7 times 6, 42. Okay, so as far as multiplying the traditional way, all that we're going to do is multiply numerator times numerator, denominator times denominator, so just straight across. Okay, so it's really pretty simple. You don't need to get common denominators. It almost makes it easier than adding and subtracting fractions. So doing multiplication the traditional way, all we do, 2 times 1, which is 2, and then across the bottom, 3 times 2 is 6, and that's it. And if we were going to compare this to the method that we did with the area model, we broke one part of the square into thirds and the other part into halves, and just shaded in however many it said. So if I'm doing 2/3, I would have 2 of those parts shaded in like that. And then the other direction, if I cut it in half this way, and then if I shaded one of those halves, which would be like this, right? Then I would be looking at, well, how many parts overlap. I have 2 parts where the shadings would overlap, and I've got a total of 6 parts, right? So I get 2 over 6. Now, you can see that this just multiplying is quicker and easier, but this is just a visual representation of how we multiply those fractions and get the answer of 2 out of 6 total. Okay, here we're just, again, multiply 1 times 1 and 3 times 4. And so we're going to get 1 times 1 is 1, 3 times 4 is 12. And if I show this with my diagram again, thirds one way, and if I color in one of those thirds, and then if I go fourths the other way, and if I fill in one of those fourths, oops, if I go one of those fourths, and then look at what I have for overlap, I can see I only have one spot that overlaps, and I've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, that's just the visual at 1 out of 12. There's the visual representation of multiplying those out. Okay, so now we're just going to multiply. We're not going to draw the area models anymore. So remember, if you have a whole number like 7, that's the same as writing 7 over 1. And that allows us to just line up our numerators, 7 times 2, and then our denominators 1 times 5, and multiply across. So I would get 14 over 5 for that one. Okay, so more practice, just multiplying a whole bunch of fractions the traditional way. 3 times 4 and 4 times 5 gives me 12 over 20. And 5 times 1, 7 times 2 gives me 5 over 14. Here I've got 2 times 1 and 3 times 2. So that's 2 over 6. This one, 3 times 2 and 5 times 7. 3 times 2 is 6. 5 times 7 is 35. Number 5, we've got 2 times 3 and 9 times 4. 2 times 3 is 6. 9 times 4 is 36. And number 6, 5 times 1 and 4 times 9. So I've got 5 over 36. And with the last one, I've got 4 times 5 and 5 times 6. Okay, 4 times 5, 5 times 6 is going to be 20 over 30. Okay, and just a few more here. 6 times 2 over 8 times 3 is 12 over 24. 3 times 2 over 4 times 5, 6 over 20. And again here, you could rewrite this as 5 over 1, so it'd be 1 times 5 and 4 times 1, so I'd have 5 over 4. 2 times 3 and 10 times 4 would be 6 over 40. And again here I'm going to write this 4 over 1, So 5 times 4 and 9 times 1 would be 20 over 9. Okay, so multiplying traditionally is pretty easy. Just multiply straight across. Okay, so we're going to do a little introduction to some angles. So an angle is made up of two rays that come together at a point which is called the vertex. So the vertex is this point right here, okay? And we just use a letter on that vertex. So we'd say an angle with vertex A, that's what we have right here. So we could call it angle A, that's your angle symbol, just that little acute angle that they draw. And it's one way to name the angle. If you have other letters on the angle, you can also use 3 letters as long as the vertex letter is in the middle. So I could say angle BAC or angle CAB. Okay. All right, in the problem solving piece here, we're going to work on, they give us a protractor to draw some angles. So this one says draw an angle that measures 90 degrees in the protractor so that the rays are 5 centimeters long. I'm not going to worry too much about, we don't have any rulers to measure the centimeters, so let's just worry about trying to draw the correct angle. So we want to concentrate on the angle that we're going to draw. Okay, now I think if you're doing this, if you saved it to your OneDrive and you've opened it up, I think that you should have this little, see I've got some shapes right there. If you tap on that, it allows you to use this arrow tool, which is kind of nice for doing this. So if we're going to draw a 90-degree angle, so always start with your pencil right here in this little middle bar that goes up and down right here. Start there, and then your initial ray is what we call it. The first one always goes out to 0. So you just kind of make a horizontal ray that goes out to the right. So that's the way we start that. And then we want to go 90-degree angle. So we go back to this spot and we go straight up through 90 the best that we can, and that is going to give us our 90-degree angle. Okay. I want a little bit bigger there. I'm gonna.
Please pardon the interruption, students. Just a reminder, if you're here for after-school path, please come on down to the Commons. Once again, students, if you're here for after-school tutoring, please come on down to the Commons.
Okay, so there's our 90-degree angle. Okay, next one, we want to do 130. Okay, so always start going horizontal ray out to 0. And then 130, okay, well there's 135. We're going to go just a little bit less than that, so a little bit on the kind of the right side of that. So go back there again, and so we don't want to go all the way to 135. We're going to kind of come back a little bit to the left of that, so something like that would be 130, a little bit less than 135. Okay, next one. So it says use number sense to draw the angle that measures 60 degrees. Okay, so 60. First start out at 0, and then 60 is going to be between 90 and 45 in here, but probably a little closer to 45. It's 30 degrees away from 90, but only 15 away from 45. So let's draw it somewhere, maybe about there, a little closer to 45 than to 90. Okay. All right, next one we have to do 170. Okay, so we're going to do 170. So always start going out to your 0. Right there. Now, over here, 180 would be straight. That would just be basically a straight line across, but we're going to go a little less than that. So 170 is going to be kind of a little bit up like this. Still going to be an obtuse angle, you know, pretty wide, but a little less than 180, so it's not a straight line. And let's see, this one we want to go 20. We'll go 20 degrees. So if we start out this way at 0 again, and 20. So notice that 45 is there. We want to go, you know, less than that, you know, even a little bit less than half of that. So maybe about right there, 20-degree angle. Okay. And the last one we're going to go 88. Okay, so 90's here, which would be just a little less than 90. Okay, so we start again with our first ray going out this direction to 0. And 88 is going to be almost straight up to 90, but just a little less than that, so something like that. Okay, and that's all of them. So it'll work with angles and then multiplying the traditional way.